Welcome and good morning. In today's class, we will see response of a diode for a AC supply. Now let us go and start it. Diode in AC circuit. Now let us get the components. You need AC source, diode, load, current measurement and voltage measurement. Now go to SIMULINK library. Go to SimScape, specialized technology, fundamental blocks, AC source, resistor, current measurement, voltage measurement, power guide and type. Then we need scope, and current measurement. First is the first block AC source, then current measurement, then a diode, then load. Output of AC source to input of current measurement, output of current measurement to anode of diode, from cathode to resistor, and from resistor to AC voltage source. Next, measurements. Now I am going to have three measurement. One across source, second one across the diode, and third one across the load. Next, RMS block. Again, as we are having three voltage measurement, we need now let us connect the output of voltage measurement to RMS, then RMS to display, output of voltage from RMS to display, output of voltage to RMS to display. Next, assign the value of AC source. 220, peak amplitude is 220, frequency is 50 Hz. change, go to RMS block, change frequency to 50 to 20. Like this, we have to do for all the RMS. 50 to 20. Next, the number of input in scope. Here you are having one, two, three measurement, and hence we need 3 input on our scope. To get the 3 input, double click the scope, go to file, number of inputs to 3. First, source voltage. Second, load voltage. And third, current. Now, let us simulate the circuit for one cycle. To simulate the circle for one cycle, you have to give the time period as 0.2, 0.02. Now we are having 3 waveform in a single window. So now let us split the waveforms. Why current is 0? Now you can see that this is for a single cycle. One cycle. One cycle comprises of one positive cycle and one negative cycle. Now let us go to view, go to configure parameters. Now let us assign the time period value for all the waveform. You can see that the time period taken to complete one cycle is 0.02 seconds. That is from 0 to 0.01 positive cycle is completed, from 0.1 to 0.02 negative cycle is completed. You can see that this is our input and these are our output. This is our input. Let us change that. Source voltage, diode current, diode voltage. Now go to the scope and get the Legrand's. Configure a parameter, display. Once you simulate your circuit, you will get the name as source voltage measurement. This is diode voltage. This is diode current. Now you can see that for a single cycle, the diode only conducts for positive cycle. And you don't have any negative cycle. The reason is during positive cycle, during positive cycle, anode is more positive than cathode. The other way of saying is a diode is in forward bias and hence it will conduct. It will allow the positive cycle to flow from source to the load. But in case of negative cycle, but during negative cycle, what is happening? The supply changes. In positive cycle, this is positive. This point will be positive. This will be negative. During negative cycle, this is positive, and this other end is negative. During negative cycle, cathode is more positive than anode. That means the diode is in reverse bias condition, and hence it will not allow the negative cycle to flow from AC source to the load and negative. And hence you are not having your negative cycle on your output. It will conduct only for the positive cycle. Now let us go and change the simulation time to 0.025 and let us simulate the circuit and let us see what is. Now you can see you are having a number of input and a number of output, and you can here clearly see that in the input you are having positive cycle, negative cycle, positive cycle and negative cycle. But the output you are having only the positive cycle. Positive cycle, positive cycle, positive cycle. Negative cycle input 0. Voltage is 0, current 0. Positive cycle across the diode, output. Negative cycle 0. Like this it goes on. And hence, in case of AC circuit, diodes only allow positive cycle. But in case of DC, you will get a during positive cycle you will get a straight line. Sorry, in forward bias condition you will get straight line, and in reverse bias condition the output voltage and current will be 0. Now let us go and make a small change in our circuit. Now next, if we change this terminal, we will see what will happen if I change the connection between anode and cathode. For that, first let me disconnect it and flip the blocks. Now anode is connected to positive and cathode is connected to negative. Again we will see for cycle. Now I have flipped the block and I have changed the connection. Before we have connected anode to plus and cathode to other side of the source. Now I have connected anode to current measurement, so cathode to current measurement and anode to the resistor. Now let us simulate and see what is the output. Now you can clearly see that as it is reverse bias, during positive cycle, cathode is more positive than anode, and hence diode will not conduct during positive cycle. And hence diode will not conduct in positive cycle. But during negative cycle, what is happening? Negative cycle will start from here and it will end at here. During negative cycle, anode is more positive than cathode. That means here now diode is forward bias during negative cycle and reverse bias during positive cycle. And hence it will not conduct in the positive cycle and it will conduct only in the negative cycle. Again, let us change time period simulation runtime for a different value, and now let us see again. Here also you can see that at the output you are having only negative cycle. The positive cycle has been clipped by the diode because during positive cycle cathode is more positive than anode, and during negative cycle anode is more positive than cathode. This is reverse bias, this is forward bias. This is reverse bias, this is forward bias. Now let us again change the connection of the diode and change it. Now you can see that again you are getting the output for only positive cycle. The negative cycle is clipped at the output by the diode. That means the energy is off of your input. At the output you are receiving only half of the energy from the input. You are only having the positive cycle. You don't have any negative cycle. The reason is conduct only in forward bias. During negative cycle it do not conduct. Thank you. Next we will see the other functionality what we are having in our scope. In scope, go to tools and go to the measurement. In first measurement you are having trace selection. To select this, you can select a particular trace. Next go to measurement and go to cursor movement. Here you can measure the waveform using by placing your cursor. You can see that when I am changing the cursor, here the value changes. Here I can get both x-axis and y-axis value, that is voltage and time period. See, it will give you voltage and time period. By using this cursor, I can measure the waveform value. Next, go to measurement and uncheck this box. Next, go to measurement, go to signal statistics. When you run, you can see that it gives the signal statistics for diode voltage. Now let us change for source voltage. It gives your statistics. Maximum is 200, 200, 220. Minimum is minus 220. Time period is The simulation runtime is 0.025. Peak to peak value is 440. It is 220 plus 220. This is mean value, median value, and RMS value. RMS value is 108. And again you can see the signal statistics for each individual waveform. First is for source voltage, next for diode measurement, then for diode current measurement. This is called as trace selection. Next, let us go to the thing. Next, let us see. Now let us go all of this. What is the next level? Bi-level measurement. And again it will give you the, here what is the difference between other and this is, here it will give you high value, low value, amplitude, edge, rise time, slew rate, edge, fall time, slew time. Here it is no use, but another thing you can use it. And here you can see the number of cycles. What is the number of cycle here? The period is 21 millisecond. 21.82 millisecond. Frequency is 45.8. Pulses, you are having 12 pulse. With this 6.618 second. This is called as bi-level measurement. This will be useful when you are using pulse width modulation technique. In the future, you will use it. Next, the last thing, peak finder. You can see that when I check the box, it will show you the peak value. It will show you the peak value. This will enable you to find the peak value. Here, all the peak are having same value, and hence you are getting same value. It will be useful for a waveform for which you are having multiple peaks with different values. This is called as peak finder. Now let us select the first source. Now you can see that I have selected the first waveform and I have opted for peak finder. It gives the value. That means let me exit. Select the second waveform. Go to tools. Peak finder. Now you are enabled to peak finder for second waveform. Now I will enable the peak finder for third waveform. By using this, the scope by itself, it will give you the values. We don't need to measure these values, the peak value, physically by ourselves. By using this button, you can have the values that you can have the values measured by the scope itself. The next thing is print. Go to file, print, and you can print the output to a PDF if you are having it. Now the output is printed to your PDF, and I can easily take this as a printout. Thank you.